Welcome students. Today again we are going to start with the next topic in the what are the strain gauge rosettes. First we have discussed the introduction part. Second we have come across the 2-element rectangular rosette and 3-element rectangular rosette. Now we are discussing about 3-element delta rosette. Before going to this 3-element delta rosette, just left out some part in that 2-element rectangular rosette. I just want to clarify one more time. That is the principal stresses. Actually, from technical reasons, it's the video have not been completed. I have done this sort of the principal directions. After that, principal stresses. How you are going to determine the principal stresses? So as you know, you have the equation, previous equation, that is sigma 1 is equal to epsilon, so this is capital E into epsilon 1 plus nu into epsilon 2 by 1 minus nu square. So this is the basic equation. So you have to determine the principal stresses by using the whatever the values you have got earlier. Okay, so I got the equation for the epsilon 1 and epsilon 1 and epsilon 2. So these are the equations obtained for the 2-element rectangular rosette. So in the problem, so what you do, you just substitute the values and you will find out that whatever the values of epsilon 1, and similarly you are going to substitute in here also, and you are going to get the value of epsilon 2. So after that, what you do, you directly substitute the values in this equation. So sigma 1, that is epsilon capital E into epsilon 1 plus nu into epsilon 2 by 1 minus nu square. Similarly, sigma 2 is equal to capital E into epsilon 2 plus nu into epsilon 1 divided by 1 minus nu square. That is the sigma 1 and sigma 2 principal stresses which you are going to determine. But in the relation wise, if you determine the sigma 1, you can see this relation you are going to get. Means you have to substitute the epsilon 1 equation which you have got earlier and epsilon 2 equation which you have got earlier, and you have to simplify this equation, and you are going to get this equation, that is sigma 1 is equal to E by 2 in the bracket epsilon A plus epsilon C by 1 minus nu plus of 1 by 1 minus nu in the flower bracket epsilon A minus epsilon C whole square plus 2 epsilon B minus epsilon A minus epsilon C whole square. Closing the flower bracket, you are going to get that whatever the root 1 by root 1 by 2. So okay, so this is the equation you are going to. Similarly, you are going to get the similar equation for sigma 2, only the sign changes in here. Okay, so this type you are going to determine the sigma 1 and sigma 2 in the 2-element rectangular set. Next, you are going to determine maximum shear stress. So maximum shear stress is also, you are having the earlier basic equation, that is tau max is equal to E by 2 into 1 minus nu into gamma max. So gamma max is obtained by this above equations. Okay, so gamma max you are going to get in this equation. This is the gamma max value. So you are going to calculate this gamma max and you are going to substitute that gamma max in this equation. So you are going to get the value. Okay, but for the expression wise, if you are going to substitute that equation in here, and you are going to find tau max is equal to, by simplification you are going to get this form, A by 2 into 1 minus nu in the bracket epsilon A minus epsilon C whole square, that is the root of epsilon A minus epsilon C whole square plus 2 epsilon B minus epsilon A minus epsilon C whole square, closing the flower bracket to the power of 1 by 2. So it is in the root. Okay, so that completes the 2-element rectangular rosette. Okay, while in the problems, don't worry about these expressions. For a derivation only you are going to get these expressions. Just remember this basic equation, and you have to remember these equations, epsilon 1 and epsilon 2 equations, because it is very much necessary. If you solve this, you are going to get these values. You are just substitute here and you are going to get the sigma 1 and sigma 2 value. Okay, now we move on to the next topic, that is 3-element delta rosette. It's a very similar type of rosette, but in here the angle of inclination is going to be changed. You can see the diagram in here. So delta represent this shape. Okay, it's a delta shape. Okay, you can also represent delta rosette in this type shape. You can see this is the A gauge, this is the B gauge, this is the C gauge. Okay, In the A gauge, you are going to have one strain gauge, means it is going to be making the inclination with the x-axis, it is 0. Similarly, in the whatever the B axis, the B gauge is going to make 120-degree inclination. Similarly, the C gauge is going to make 240-degree inclinations. So like that, if you come to this diagram also, this is the first A gauge, this is the this is the B gauge, and this is the C gauge. Okay, you can also form the arrangement like this. So first gauge is going to make 0-degree, the second gauge is going to make 120-degree, and the third gauge with respect to this parallel line. Okay, if you make a parallel line of this line, it can make a 240-degree inclination. So like that it's going to be there. Okay, so you can see here the similar values which are given here, that is theta A is equal to 0, theta B is equal to 120, and theta C is equal to 240-degree. So substitute in main equations, the basic equations you have to substitute for to determine epsilon xx, epsilon yy, and gamma xy. So similarly you have substituted in the basic equation. This is the basic equation where theta A is provided for the epsilon A. Wherever theta A is there, you are going to substitute 0. Okay, and simplifying, after simplifying, that is sin 0 is equal to 0, in here also sin 0 is equal to 0, so this term going to get 0, and similar this is also going to get 0. Only this term where sin cos 0 is equal to 1. So what happens, you are going to get the one value, that is epsilon A is equal to epsilon xx. So similarly, if you substitute for the next epsilon B expressions, the equation, in the terms of theta B, you are going to substitute 120. Similarly, you can see here 120, 120, and 120. So what is this cos 120? The cos 120 is nothing but minus of 1 by 2. Okay, so cos square of 120 is nothing but it is going to be 1 by 4. Minus minus get cancels, and 1 by 2, 1 by 2. If you multiply that, you will get 1 by 4. Similarly, epsilon y sine square means sine 120 is equal to root 3 of 3 by 2. Okay, you are going to substitute, and if you square that, you are going to get 3 by 4. Okay, similarly in here gamma xy, cos 120 minus 1 by 2, sin 120 root 3 by 2. So if you simplify that, you are going to get this equation, epsilon b is equal to 1 by 4 epsilon xx plus 3 epsilon yy minus root 3 of gamma xy. This is the equation. Similarly, if you epsilon b, how you are going to determine epsilon b? By putting this cos 120 in the place of cos 120 in the epsilon c equation, you are going to put 240. So after simplification, in a similar way, you are going to get the equation 1 by 4 into epsilon xx plus 3 epsilon yy plus root 3 of gamma xy. Okay, this type you are going to calculate. Okay, what you do, we don't want this epsilon a, epsilon b, and epsilon c. We want epsilon xx, epsilon yy, and gamma xy from these expressions. Okay, so similarly what we do, we are going to interchange the values. Here epsilon xs we directly get epsilon a, so we have written that epsilon xs is equal to epsilon a, and epsilon y is equal to, what you are going to do, you are going to just substitute the values. Okay, epsilon xx and whatever the values epsilon yy, you are going to substitute that values you are going to write in here, that is epsilon ay is equal to 1 by 3 into 2 epsilon b plus 2 epsilon c minus epsilon a. Means you have to simplify these things. Okay, these two expressions what you have got here, epsilon b and epsilon c, if you simplify these two equations, you are going to get the values of this epsilon b and epsilon b and epsilon c equations you are going to get. So by that you are going to get these expressions. Okay, epsilon y is equal to 1 by root 1 by 3 to epsilon b plus epsilon 2 epsilon c minus epsilon a. Similarly, gamma xy is equal to 2 by root 3 epsilon c minus epsilon b. Okay, like that you have got the three values. Now similarly as in earlier stage, we have to determine the principal strains epsilon 1 and epsilon 2. So for to determine the epsilon 1 and epsilon 2, you have the basic equation for the epsilon 1. Okay, since delta strain gauge is having some different type of arrangement compared to the known value of arrangement. So in here you have to take a basic equation for to solve that. Okay, that is epsilon 1 is equal to 1 by 2 epsilon xx plus epsilon yy plus by 2 epsilon xx minus epsilon y whole square plus gamma xy square. It is in the root. Okay, this is the expression. So in this expression you have to substitute the epsilon xx, epsilon yy and gamma xy values. Okay, you can see here epsilon 1 means it is a simplified equation. You can directly remember this, or you can substitute the epsilon xx values in here in the basic equation and you can determine the epsilon value, one value, okay, in the problems. Okay, or you can find these expressions for the for to give the relations. Okay, so you will get the expression as equation as epsilon 1 is equal to 1 by 3 epsilon a plus epsilon b plus epsilon c plus of half into the root of epsilon a plus epsilon a minus 2 epsilon b minus 2 epsilon c by 3 whole square plus 2 by root 3 epsilon c minus epsilon b whole square. It's in a flower bracket root. Okay, 1 by 2 to the power 1 by 2. The same similar expression for the epsilon t 2. Okay, next what you are going to do, you are going to determine principal directions. You know the basic equation, that is tan 2 phi is equal to gamma xy by epsilon x minus epsilon y by. What you do, just you substitute the values in here. Okay, what they had done, they had substituted the expressions in here. Okay, this is the expression of gamma xy. These two expressions are substituted in here. Okay, so like that you are going to get the principal directions. Okay, so next principal stresses. As I said, this is a big expression is going to be there for the principal stresses in the delta rosette. You can just go to this basic equations only, you can substitute the values and you are going to get the expressions. But when you are in the problems, if you want to solve the problems, don't go for the solving the big expressions. Just to find out this epsilon 1 epsilon 2, substitute here and find the sigma 1 and sigma 2 value. Okay, this is the basic equations. Okay, we have not elaborated here, so you can elaborate and you can get the expressions. I have provided the notes where you can get the elaborated expression for sigma 1 and sigma 2. Okay, so with that we have completed the types of what are the rosettes. That is 2 element rectangular rosette, 3 element rectangular rosette and delta rosette. So these are the 3 important rosettes. So you have to understand the expressions, how these expressions have came. While in determination of values, that is stress value, strain value, that can be determined by these expressions. Okay, that is the main part. You have to understand the main concept in here, to understand how the strain gauge values are going to be converted and it can be used for the stress measurement. Okay, as it's an experimental stress analysis method, one of the method, so you have to experimentally know how it's going to be measures. Okay, thank you students. I think I have given some instructions which may help you in your learning process. Okay, don't neglect, because nowadays you know what is the situation. So the lockdowns may open for or it can be go for a further lockdowns. So you have to regularly study these things and you have to get ready for the next internals, exams, everything. So don't know what is the future scenario of these things. So we are going, I'm trying to give whatever the requirement is for your syllabus purpose. I will try to make videos as much as possible. So don't neglect, just follow things. If you have any queries, just message me or call me. Just ask any questions regarding this subject. Okay, I think it will be helpful for you. Okay, bye. Thank you for listening.